I am Krishnapriya MK, working as Assistant Professor in the Department of Soil Science and Agricultural Chemistry. And today I am here as a mentor in the discipline of Physical Science. And we know that our JRF examination is scheduled to be conducted on July 3rd. So it's already time up to start the preparation seriously. So first of all, I want all the students to have the course outline or the syllabus of this examination and go through the syllabus well clearly. When we go through the syllabus, we can see that our total soil science subject has been divided into different sub-disciplines like soil physics, soil chemistry, soil biology and soil fertility. So when you go through the previous year question papers, you can relate that there are different questions which has been asked from each of these disciplines which I have mentioned before. So we'll directly move to the first question. The first question, it is the match the following. So here in the first column we can see that different theories has been given and we have to correctly match it with our second column. So the saturated flow in soil, soil texture analysis, wavelength of emitted radiation and the diffusive flux of gas. All these are the physical properties of soil and we have to match it which law will be correctly specifying these phenomena. So the first is the saturated flow in soil. So when we look at this column 2, we can see Rain's law, Darcy's law, Fick's law and Stokes law. So if we have studied all the syllabus, it will be very clear that the saturated flow in soil, it is directly dealing with the Darcy's law. And the second B, it is the soil texture analysis and the law which we follow in order to know the texture of the soil, it is the Stokes law. And we know that soil texture means it is the relative proportion of sand, silt and clay. So when you go through these terms, you have to relate it with all other physical parameters like soil structure also. Soil structure means it is just the arrangement of primary particles. And the C, it is the wavelength of emitted radiation. So it is related with the Wayne's law, and the last, it is the diffusive flux of gas and it is directly related to the Fick's law. So when we look at the options, option 3 correctly matches with all these parameters. So the correct answer is option 3. Now coming to the second question. This question, it is an assertion reason type. So when we go through the previous question papers, you can see that in previous year it was like direct questions and we will be able to find the answers correctly. But nowadays there are assertion reason type. So only if we know the concept of the matters, then only we will be able to give the correct answer. So we will just read the assertion here. Gypsum is only used for the reclamation of sodic soil, and the reason they are given as reclamation process, it involves the reduction in exchangeable sodium with calcium and its removal from soil solution through leaching. So first of all, we will see this is related to the soil chemistry portion. So gypsum, it is being used at the reclamation of sodic soil. So first we should know how this sodic soil is being formed. So sodic soil, it is mainly formed because of the carbonates and bicarbonates of sodium compound. And gypsum, the chemical formula of gypsum, everyone knows that it is calcium sulfate. So now we are applying this calcium sulfate in order to manage the sodic soil. So the reason they have given us, so we should remember the clay colloids here. We know that on the clay colloids in sodic soil, it will be sodium will be dominantly present. So as we are applying the gypsum's chemical formula, it is calcium sulfate. So that calcium will go and bind with the clay complexes which is already filled with the sodium. So that clay will replace the sodium and then the clay complex will be rich with calcium and all the sodium, it will be leached out in the form of sodium carbonates. So this can be the correct answer for the assertion they have given. So the answer given here is, that is both A and R is correct, and reason it is the correct explanation for the assertion. Now the third question. So here it is related to the soil fertility and the soil nutrient. So here the deficiency symptoms like discoloration of leaf buds, breaking and dropping of buds. So these deficiencies are caused by which element? That is the question. Options: boron, molybdenum, iron, magnesium. So every JRF examinations, in every examinations, if you go through the papers, you can see that like the similar questions is been repeatedly asked, like deficiency symptoms, and they will be given and you will have to answer which this deficiency is caused by which nutrient. Not only deficiency but also the toxicity was also being asked. So here in this case, all these symptoms like the discoloration of the leaf bud, the breaking and the drooping of buds, everything is due to boron deficiency. And boron, as it is slowly immobile in plants, these will be given or this will be shown in the young tissues. So like this, different questions used to be asked like pahala blight of oats, grey speck in oats, pahala blight in sugarcane. All these are due to magnesium deficiency. So you will have to write and study the deficiency symptoms of each peculiar nutrients. And for a very single nutrient, they will be showing different deficiency symptoms. So you have to go through all the deficiency symptoms that is caused by each and every nutrient. Now the fourth question, the elements associated with the nitrogenase enzyme in biological nitrogen fixation. So this question, it is coming under the soil biology aspect. We know that the biological nitrogen fixation, what is that process called? That atmospheric nitrogen, it has to be converted into ammoniacal or the nitrate forms. Why? Because these plants, it can't take up the nitrogen as such from atmosphere. It has to be converted into some easily available forms by plants. And the plants, they usually take up the nitrogen mainly in the form of ammonia and nitrate. So the conversion of this atmospheric nitrogen to ammonia is known to be the ammonification, and thereby it will be converted to nitrate, and this whole process we can call it as biological nitrogen fixation. And for this process they require a particular element. So the question is, which of these elements are required for the easy working of this enzyme nitrogenase? So here molybdenum, iron, copper and nickel is being given. So many of you will be knowing that for the working or this, for this purpose of this nitrogenase enzyme, molybdenum is a requirement, but along with molybdenum, iron and nickel is also involved in this activity of nitrogenase enzyme. So thus the answer becomes one, that is, it includes both all the molybdenum, iron and nickel. Now the fifth question, the motile leaf of citrus is caused by the deficiency of. So again this is like a repeating question, that deficiency symptom is given and we are asked to find this particular deficiency is caused by which of the nutrient. So motile leaf of citrus, it is mainly caused by that of zinc deficiency. Now the sixth question, this is the Bray number 1 reagent is. So this Bray number 1, you can't find these questions or these type of things in your theory portions, because this Bray number 1, it is related to our practical classes. So in the practical classes we might have come across this reagent Bray number 1, and we should know this reagent, it is peculiarly used or specifically used for the estimation of available phosphorus, that too in acidic soils. So that much we will be knowing. But here the question is, the Bray number 1 reagent, it consists of some of the chemicals. Which are those chemicals? That's the question. And if you have studied, you may be knowing that it consists of ammonium fluoride and HCl. But again, see the question pattern, they have been more specific. This is the peculiar features of this JRF or SRF examination. The options, they will be given as too specific. See, when you look at the number 3 and 4, the options 3 and 4, both the chemicals, that is ammonium fluoride and HCl is the same, but they have changed in the molarity and the normality. In option 3, it is 0.03 molar, whereas in option 4, it is 0.03 normal. So unless and until you study things very peculiarly, you will not be able to give this correct answer. So here the answer is 4, that is 0.03 normal ammonium fluoride and 0.025 normal HCl. Now the seventh question, the microorganism that oxidize ammonia to nitrate. So as I have explained before, in the process of biological nitrogen fixation, that atmospheric nitrogen has to be converted to ammonia, then to nitrite, later at last it will be converted to nitrate form. So this whole process is known to be the biological nitrogen fixation, and in all these steps peculiar microorganisms are involved, because these conversions are made enabled only with the help of microbes. So here the question is, which is the microorganism that helping in the oxidation of ammonia up to nitrite? The question is not up to nitrate, it is only up to nitrite, NO2. So here from these options we have to choose the correct answer. The options include Nitrosomonas, Thiobacillus, Nitrobacter and the Nitrosolobus. So here the answer comes both the Nitrosomonas and Nitrosolobus. These two are the microbes or bacteria which are enabling the conversion of atmospheric nitrogen, that is ammonia, to nitrite. So all these soil biology, it greatly deals with the microorganisms, different bacteria, fungi and all, and we have to be familiar with all their roles. Now we will move to the eighth question. So this question is also related to the analytical chemistry part. So we have to match the first column correctly with the second column. So the first is Geldal method. Geldal method, we know that it is related with nitrogen. So we will see for the options. It measures, yes, the third one, it determines the total nitrogen content in the soil. So when we go through these options, the A, it will correctly matches with the 3. So that we need not look at other options, because the other options, it is A, it is matching with 1. And we have already found that Geldal method, it is already used for the nitrogen estimation. So we can directly take this as the answer. So option 4 will be the correct answer. So that we can save much time here. Now the ninth question, in the International Union of Soil Science Classification System, fine sand has a size range of. So we should know that there are two types of soil classification system. One is the International Union of Soil Science and the other one it is USDA, United States Department of Agriculture, and both these classification system has got a peculiar range of for all these soil particles like sand, which has been again divided into fine sand, coarse sand, then silt and clay. So if you study this is a direct question. So here the answer comes 0.02 to 0.2 mm. That is the size range of fine sand. The next question, this is a frequently asked question for most of the examination. The characteristics of saline alkali soil. So this is coming under the problematic soil portion. So you have to study this pH, EC, ESP, SAR values of all these saline soils, saline alkali soils and alkali soils. This alkali soils is also sometimes known to be the sodic soils. So you have to know the pH, EC, and here the SAR is not been asked. It is only pH, EC and ESP. So the saline alkali soils, it contains greater pH of 8.5, greater EC of 4 decisiemens per meter, and ESP it is less than 15. So the option comes as 2. So these were the questions that had appeared for the 2024 JRF examination. So like this, we will be discussing most of the frequently repeated questions in the coming classes. So I want all of you to study the portions, revise the portions, not a study because the studying time has been already exhausted. Now you have to revise the portions that you have studied, and then when we will be discussing the questions, it will be more easy for you, and practice maximum questions as much as you can, because during this time it is rather than reading the theory, more effective will be doing the questions, more objective questions as much as you can. So by this I am winding up today's sections. See you in the next class. Thank you all.